Imagine a future where electricity never runs out, where every city, every home, and every car runs on limitless, clean energy powered by a man-made sun. This isn't science fiction. Right now, the world's biggest powers, China, the United States, and Europe, are in a race to build artificial suns, giant fusion reactors that can recreate the power of real stars. It's one of the most ambitious scientific projects in human history, and whoever succeeds first will control the future of energy. The dream of unlimited power. For over a century, humans have depended on fossil fuels, coal, oil, and gas, but they're dirty, limited, and destroying our planet. Scientists have always dreamed of a cleaner solution: nuclear fusion, the same process that powers our sun. Unlike nuclear fission, used in current power plants, fusion doesn't split atoms. It fuses them together, releasing massive energy. Just one glass of fusion fuel could power an entire city for a day, with zero carbon emissions and no radioactive waste. If achieved, fusion energy would mean infinite clean power and the end of the global energy crisis. That's why the world's richest nations are trying to build their own artificial suns. China's artificial sun. Let's start with China. In 2021, China's East Reactor, also called the artificial sun, achieved a record-breaking 70 million degrees Celsius for over 17 minutes. That's 5 times hotter than the core of our real sun. This machine uses superheated plasma trapped inside magnetic fields to mimic the fusion process. It's part of China's long-term plan to build a commercial fusion power station by 2050. The country has already invested billions of dollars, and many experts believe China could lead the world in this energy revolution. Their goal is clear: create an endless green energy supply and reshape global power. The West strikes back, USA and Europe. But China isn't alone. In the United States, researchers at the National Ignition Facility achieved something historic in 2022. For the first time ever, a fusion experiment produced more energy than it consumed. That moment, known as ignition, proved that fusion energy isn't just a dream anymore. It's possible. Meanwhile, in France, 35 nations are collaborating on a $25 billion project called ITER, the world's largest fusion reactor. When completed, ITER will weigh 23,000 tons and become the biggest scientific machine ever built. Its magnetic field will be 250,000 times stronger than Earth's, capable of trapping plasma hotter than any star we've ever created. Together, these global efforts mark the beginning of the fusion era. The billionaire connection. And of course, billionaires are joining the race too. Companies like Helion Energy, backed by OpenAI's Sam Altman, Commonwealth Fusion Systems, supported by Bill Gates and Jeff Bezos, and TAE Technologies, funded by Google, are turning fusion into a commercial gold rush. Helion claims it will produce commercial fusion energy by 2028, while Commonwealth says it'll beat ITER by years. These private firms are racing to build compact fusion reactors, small enough to power entire cities, or even starships. If any of them succeed, they won't just change the world. They'll own the world's next trillion-dollar energy industry. The science behind the star. But how does an artificial sun actually work? Inside the reactor, hydrogen atoms are heated until they become plasma, a super-hot soup of charged particles. Then powerful magnetic coils shape and compress this plasma until hydrogen atoms fuse together, forming helium and releasing enormous energy. The challenge? Keeping the plasma stable at temperatures over 100 million degrees Celsius without melting the reactor. That's where superconducting magnets, cryogenic cooling, and AI control systems come in. Every fraction of a second, algorithms adjust the magnetic field to prevent collapse. It's a dance between chaos and control, a human attempt to bottle a star. Still, we're not there yet. Fusion demands massive power input, extreme precision, and materials that can survive the heat of a sun. Building these machines costs tens of billions, and some scientists say practical fusion power may still be decades away. But progress is accelerating faster than ever. Just like flight or electricity once seemed impossible, fusion is now inevitable. It's no longer a question of if, it's a question of who gets there first. When that day comes, when the first fusion reactor lights up the world, humanity will have created its own star. No pollution, no oil wars, no energy shortages, just pure power from the heart of physics itself. The nation, or company, that controls fusion will control the future of civilization. Infonistic, where intelligence meets imagination.